Greetings, welcome to this new video about nodal analysis or node voltage method. Solve the problem number 7. Let's consider this network consisting of 4 resistors labeled R1 through R4 as well as one independent voltage source Vs. Additionally, we can observe the presence of a dependent source, especially a current-controlled current source. The question now is to use the nodal analysis to find the voltage VO. The voltage VO is the voltage across the resistor R4. Let's move on to the solution. Let's start first by labeling all the nodes in the network, and I will consider this node as node 1 and this node as node 2. After, we will assign the voltages V1 and V2 respectively to those two nodes. Next, we need to select a reference node in the circuit. The reference node is typically chosen as the node with the most connections, or as the ground node. Let's now assign arbitrarily the currents in each branch, and I will consider I1 is the current through the resistor R1, and I3 is the current through the resistor R3, and I4 is the current through the resistor R4. Next, we will proceed to apply Kirchhoff's current law in each node. Let's start first with node 1. By applying Kirchhoff's current law at node 1, we can write I1 is equal to Ix plus I2. Let's move on now to node 2. By applying Kirchhoff's current law at node 2, we can write I3 is equal to 4Ix plus I4. According to Ohm's law, the current can be expressed as the voltage difference across a resistor divided by the resistance. This implies that the current can be determined by the following equations. I1 is equal to Vs minus V1 over R1, and Ix is equal to V1 minus 0 over R2, and I3 is equal to V1 minus V2 over R3, and I4 is equal to V2 minus 0 over R4. Now, by substituting equations A, B, and C in 1, we obtain Vs minus V1 over R1 is equal to V1 over R2 plus V1 minus V2 over R3. By replacing the resistors and the voltage with their numerical values, we obtain this equation. And if we combine all the terms of this equation into a single denominator, we obtain the following equation. And if we continue simplifying this equation, we obtain finally 4V1 minus 2V2 minus 40 is equal to 0. And now by substituting equations B, C, and D in 2, we can write V1 minus V2 over R3 is equal to 4V1 over R2 plus V2 over R4. And if we replace the resistors with their numerical values, we obtain this equation. And if we continue simplifying this equation, we obtain 2V1 plus 4V2 is equal to 0. By performing 3 minus 2 times 4, we derive one equation in terms of V2. That means V2 is equal to negative 40 over 10 is equal to negative 4 volt. And from equation 4, we have V1 is equal to negative 2V2. If we replace V2 with its numerical values, we obtain V1 is equal to 8 volt. And the voltage VO across the resistor R4 is equal to R4 I4, and we know that I4 is equal to V2 over R4 is equal to V2. That means VO is equal to negative 4 volt. After completing the calculations, we conduct a simulation using SPICE to verify our results. Now let's proceed to the SPICE environment. Here is our network drawn in SPICE simulator. This is our independent voltage source Vs, and this is the dependent source, the current controlled current source, the resistor R1, R2, R3, and R4. I connect here a voltmeter in order to measure the node voltage V1, a voltmeter to measure the node voltage V2, and a voltmeter to measure the voltage across the resistor R4. Let's move on to analysis. This analysis calculate nodal voltages. We can see here that V1 is equal to 8 volt, V2 is equal to -4 volt, and VO is equal to -4 volt. Upon completing the circuit simulation, we can observe clearly the similarity between the simulation and calculation results. This serves as a validation or verification of our work. Alright, thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another video about nodal analysis. Take care and bye bye.